Okay, let's move to question number 28. You need to simplify these expressions. Okay, if you really forgot how to simplify such kind of the trigonometric ratio, don't worry. You can use a technique called substitution. For example, I substitute theta equals 10 degrees inside the expression and the option, so you can check whether which answer will be correct. And you need to do is sine 190 degrees times tangent 280 degrees over cosine 370 degrees. That's you need to plug in. So let's try. Sine 190 degrees multiplied to tangent 280 degrees divided by cosine 370 degrees, and luckily you get 1. So check the options. You will find that A is the only answer. As you know, C and D, when you substitute theta equals 10 here, you will not get 1. So answer A here. For question number 29, 3 lengths are given, 10 cm, 4 cm, and 2k cm respectively, and you need to find the area of this triangle A, B, and C. So how do we start with? As you can see that we can try to use Heron's formula. Of course, that's the usual method to do this, and S, that is equal to 10 plus 4 plus 2k and then over 2, then you will get 7 plus k. So the area will be S times S minus 10 times S minus 4 times S minus 2k. Of course, take a big square root. So you will get that is square root 7 plus k times 7 minus k times k minus 3 times k plus 3. Then you will get the answer can be simplified as 49 minus k squared bracket times k squared minus 9. So you can check that is answer A. That is a usual method. But try to think in another way. You can use triangle inequality. That means the sum of two lengths of the triangle must be greater than third one. So if you try in this way, that means 10 plus 4 must be greater than 2k, and that means k is actually less than 7. Okay? It cannot equal to 7, must be less than 7. Alright? And also 4 plus 2k must be greater than 10, and that means k should be greater than 3. When you need to satisfy these two conditions, that means k must lie between 3 up to 7. So let's check some numbers. Okay, if k is between 3 to 7 only, and remember, when k does not lie between this range, then the triangle does not exist, and that means the area of triangle cannot be found. So we can try to substitute some value which is not lie on this range. For example, k equals 2. When you sub k equals 2, A cannot be obtained, B could not be obtained, but C could be obtained. So C is not the option. And D, when you substitute k equals 2, you can find the area. That means D is not the option. Alright? So in other case, when substitute k equals 8, okay, we substitute k equals to 8, you can find that B, the area could be found. That means B is not the option. So the final possible option is A. You can use triangle inequality to deduce the answer if you really forget the Heron's formula. So question number 30, quite standard question about using cosine formula. So cosine theta would be 3 square plus 4 square, okay, the sum of the square of these two lines minus the opposite side square, 2 square, over 2 times 3 times 4. And you can get the answer cosine theta, that is 7 over 8. So the answer is D. That's quite straightforward. And for question number 31, you need to find the length, the ratio of AD over AB. So let's see what we can do. Okay, in this one, you may assume AB is 1. This is an MC question. So the question, it becomes, if AB equals 1, then what is AD? Alright, so let's see what we can do. We can find CA. Why? Because CA is the common line of these two triangles. That's a very important method to find the angles or the length in trigonometry. Find the common angle or common side. So CA would be tangent beta, and CA over 1, that is tangent beta. Okay, so look at the second one. You need to find AD. So AD over the hypotenuse tangent beta will equals to cosine theta. So it's alpha. So AD actually that is cosine alpha times tangent beta. Therefore, the answer is A. Because AB is 1, so you can add this one. So final answer A. For question number 32, there's a cube. It's sort of cuboid A, B, C, D, E, F, G, H, and the length, width, and height are different. The base, the angle between triangle ACE to the plane ABCD is theta. You need to find tangent theta. Oh, so there's a face ACE and another face ABCD. First of all, you need to find the intersecting line. That is AC. And in this line AC, you need to draw the perpendicular line from each face. So this one and this one. Some of you may wonder why they can connect at the same point, because based on free perpendicular theorem. Okay, if ED is perpendicular to the face ABCD, and I let this one be K, and DK perpendicular to AC, so when D is moving up to E, EK also perpendicular to AC. But how do we find this angle theta? Theta, that is angle EKD. So let's look at the triangle DAC. AD actually is 3, DC actually is 4. You need to find this height DK. AC you can find it easily, that's 5, by using Pythagoras theorem. So consider the area of the triangle ACD. 3 times 4 over 2, that's 6. 5 times DK over 2, that's the area, also 6. Therefore, DK 2.4. And hence, you can find tangent theta now. Tangent theta will be DE, that is 6. And then over DK, 2.4. So, simplify this. 6 divided by 2.4. Press the button. You can get 5 over 2. Okay? So the answer will be C. 5 over 2. And for this one, question number 33, and which of the graph may represent y equals 1.6 to the power x? Okay, when you substitute x equal to 0, what happened? Y equals 1.6 to the power 0, that's 1. That means it's passed through the point 0, 1. Or you can say the y-intercept is 1. Hence, boy and dog are not the answer. Now, try another point. When x is equals 1, y, of course, that is 1.6. So what does that mean? That means it's greater than 1. That means it will going upward from left to the right. And hence, A is not the answer. Because when you find that x is 1, it will a bit lower than the height here. So A is not possible, and final answer would be C. So question number 34, you need to find the relationship between x and square root y. So you treat this one as a straight line, but what we can do is you can treat this one as a vertical variable, something like this, equals the slope of the straight line, that is 8 minus 0 over 0 minus 4, that is the slope of the straight line, times the horizontal variable x plus a vertical intercept a. That's the way you should write down. So square root y, that would be equals to negative 2x plus 8, and hence you can make y the subject. Negative 2x plus y bracket square, so it can be expanded to become 4x squared minus 32x plus 64, and so the answer is C. Remember, it is the slope-intercept form. It not just apply to the xy coordinate only. If that is the coordinate, this is a horizontal intercept heart, and that's a vertical intercept triangle, you always can write the equation in this way: triangle equal to slope of straight line times heart plus the vertical intercept k. You can always write in this way. Okay, let's move to question number 35. Denotes the circle 2x squared plus 2y squared blah blah blah, and you can see the coefficient of x squared and y squared is not equal to 1. So divide the whole equation by 2, become x squared plus y squared plus 2x minus 6y plus 7.5 equal to 0. Find the center and radius. Center, negative 2 over 2, negative 6 over 2, that is negative 1, 3. Radius will be square root negative 1 bracket square plus 3 bracket square. Okay, the x coordinate of center bracket square plus y coordinate of center bracket square minus the constant term 7.5, then you can get the radius, that is, let me use the calculator, the square root 2.5, that's 1.58113883 something. Okay, you need to find the area of this circle. So area, that would be pi times r squared, that is pi times 2.5, that is not 25 pi, so 1 is not the answer, so we just cross them out, option 1. Okay, and that just left B and D, and you can see that 2 must be in the option, so do not need to check statement 2, just check statement 3. Center of C lie on third quadrant, negative 1, 3, that is in second quadrant, not the third quadrant, so statement 3 is not correct, and the final answer is B.